All right, so today we're going to start thinking about the inverse of the sine function. So if we're thinking about the sine graph, we know that, it is a function. If we are graphing this sine is a function, but its inverse would not be a function. If we inverted this and we exchanged the x's and the y's, then I think we can imagine this would be doing something like this over and over again for forever, because it would invert the x's and the y's. The x's would bounce them between +1 and -1, and we would see that the domain, which is now the range of this inverted function, would be all real numbers. So this would certainly not be a function, would not pass the vertical line test, and that is because the original sine function is not 1-to-1. But in order for us to think of our inverse sine as a function, we restrict the domain. Okay, so as close to the origin as we could, we choose a section of the sine function that gives us all possible outputs, all the whole range between -1 and +1. And the simplest way to do that is to think of our restricted domain, which is from a -π/2 to a +π/2. That is our restricted domain. So now when we graph our inverse sine function, check it out right here, it doesn't go on forever because we've restricted the original domain of our sine function. So now our inverse is a function. If we were to continue this any further, it would come back this way and continue that oscillation. But, so now when we talk about inverse sine, we are going to think of a restricted domain on our regular sine, meaning that on our inverse sine, our inputs are between -1 and +1, and our outputs are between -π/2 and π/2. Inverse sine can be written in two different ways. We can see it like this, or we call this also ArcSine. These mean the same thing. You'll see these interchangeably, but ArcSine is the same thing as inverse sine. And so once again, when we're thinking about our sine function, we're thinking about inverse sine values, we can look in just the first and the fourth quadrant, because that is when we're between -π/2 and π/2. Let's evaluate these. This is what we're really getting at here. We can reflect back on our unit circle knowledge to make this a lot easier for ourselves. This first one, the inverse sine or ArcSine of a half. Now, in order to get this output, you want to think, when on our unit circle was our sine value, was our y value a half? That's what we want to think of. When on our unit circle was our output a half? When was our sine value a half? What angle created this point? And we should be familiar enough with the unit circle to remember that point would be √3/2 a half. Over √3/2 up a half, that's just 30 degrees, or π/6. We're going to give these exact values in radians. Be ArcSine of -√2/2. Okay, ArcSine, -√2/2. Well, negative, we're already thinking fourth quadrant, and we probably thinking to ourselves, of course, that is going to be the √2/2 -√2/2 point. Again, it's ArcSine, we're thinking about the y value, and what gives us that? That is the -π/4, because this would be in that fourth quadrant, -π/4. You might be thinking to yourself, oh, isn't that 7π/4? That is the same thing, but remember, when we're talking about ArcSine, we're thinking about our restricted domain, we're thinking about a value between negative pi over 2 and pi over 2. That's where we want to keep our mind at. Here, inverse sine of 3. Look back on our unit circle, think about when you got 3 out for your sine. It's not possible because all of our sine outputs would be between -1 and +1. Never can we get a 3. So this does not exist. That does not exist. Because that would mean that an output of our original sine function was a 3 when the range was simply -1 to +1. And a quick tag in the problem we just did where we were finding sine, or inverse sine of a half. This just wants us to make note that, well, even though 5 pi over 6 also gives us an output of a half, again, 5 pi over 6 is not between negative pi over 2 and pi over 2. This is our restricted domain of our original sine function. So that means when we inverse it, those are our restricted outputs. So we have to be careful with that. Remember, when we're thinking about inverses, we're exchanging the inputs and the outputs.